Now there are two other forms of the Pythagorean theorem that you should know. They're not identified in books, but if you want to be successful in geometry or any higher class, particularly in trigonometry, you're going to want to know the two quick fill forms of the Pythagorean theorem. I'm not going to prove these two forms to you. You can prove them for yourself, and you will see them used in any geometry book. Unfortunately, they're not usually taught to students, and they will give you great success in trigonometry if you master them. Here's a right triangle. Let us say that you know two sides of this right triangle. And when I say know, I don't mean that you necessarily know numbers, but that they have been identified with some expression, numerical or algebraic. Let's start with numbers. Let's say you know that this side is 4, and this side is 10, and you'd like to find the third side, the hypotenuse. The quick fill rule is this. The missing side in a right triangle will always take one of two forms. It will always have a square root. It will always have two items squared. If you are looking for the hypotenuse, you square the other two sides and you add them. And that is the missing side. As I've said before in other lectures, it doesn't matter whether you square the 4 or square the 10 or leave it written in this form here. So you could have the square root of 16 plus 100. You can have the square root of 116, or you can have it in this form here. Regardless, you have filled in the missing side. Anything after this point is in the realm of arithmetic or algebra, but not in the realm of the Pythagorean theorem. Okay, let's try this again. You know two of the legs. This one is x. This one is x plus 5. You want to know an expression for the missing side. It will always be the square root of one leg squared added to the other leg squared. And that is the first form of quick fill, using it to fill in a missing hypotenuse. Anything after this is algebra. You may leave it in this form and still be correct up to this point. What if the side you're looking for is not the hypotenuse but one of the legs? So I know that this side is 20. I know that this side is 9. And I wish to find an expression for this side here. Same basic rule as the other form of quick fill. This will always be a square root. There will always be two things squared. You have to make sure that the first term is the hypotenuse, 20 squared. And then you subtract because you're looking for one of the two legs. And you write 9 squared. This almost looks the same as the quick fill for the hypotenuse. The difference is you start with a hypotenuse and you subtract. Remember that difference, and you can always quickly fill in the missing side of any right triangle. Another example. You know that this side is x plus 3. You know that this side is x minus 1. You're looking for this leg. Quick fill, write the square root, take the hypotenuse and square it, subtract the other leg, square, and you're done. When you're working a problem, in geometry or in trigonometry or in algebra 2, there will always be one of two situations. One in which you have been given three sides of a right triangle. And what is required next is to come up with an equation that can be solved or can lead you somewhere else. You'll see something like this. Whatever you see, all three sides will be expressed. In that situation, you're going for an equation. And you use Pythagorean Theorem in the traditional form to produce an equation. Orient yourself. Then this side squared plus this side squared equals this side squared. And then you go on from here to wherever you're required to go. On the other hand, particularly in trig, you will be presented with a situation in which you have a right triangle, usually on some other surface or on some other coordinate system. It's just sitting there. And you'll be required to fill in a missing side. Perhaps you will know that this side here is a -4. And yes, that can happen in the world of trigonometry. And this side will be a 6, and you'll be asked to find that side there. Use quick fill. You're looking for a hypotenuse. It's the square root of this side squared plus this side squared. And you will now have sufficient data to answer all the rest of the questions about that triangle and what that triangle is in reference to. And that pretty much covers the three forms of the Pythagorean theorem.